Hi, my name is Nur Shahzadani Badra binti Nama Azmi. My number machine is 2023 444 544. So today I will talk about the introduction of metacentric height. So basically, the metacentric height, which is GM, is a measurement of the initial static stability of a floating body. It is calculated as the distance between the center of gravity of a ship and its metacenter. A larger metacentric height implies greater initial stability against overturning. The metacentric height also influences the natural period of rolling of a hull, with a very large metacentric height being associated with shorter periods of roll which are uncomfortable for passengers. Hence, the sufficiently but not excessively high metacentric height is considered ideal for passenger ships. So, for the objective, to identify the position of the metacenter of a floating body by determining its distance from the center of gravity. Then I will explain about the problem statement. So the problem statement is students are required to conduct an experiment on determining the location of the metacenter by determining its distance from the center of gravity, where the distance metacenter is known as the metacentric height. Students should be able to use the technical data from the experiment or using their own measurements. All readings and data from the experiment should be converted to appropriate units and tabulated accordingly. Then, students are required to plot a graph metacentric height.
When in equilibrium, the boat experience two forces. It weight acting downward from the center of gravity and buoyant force from the water upward acting from the buoyancy point. Both these points are joined in a straight line, which called the center line, and the imaginary point metacenter will lie on the same line. Note that the buoyant point is located on half the depth of the total length of boat immersed in the water.
My name is Nur Shahzadani Badra binti Azmi. My number matric is 2023 444 544. Okay, today I will explain about the metacentric height apparatus. So basically, this is the jockey weight. So we can move it to the right and the left. And this is the ruler to measure the jockey weight in millimeter. And this is the scale ruler in degree to measure the plumb bob when this metacentric height in the water. Last but not least, this is the adjustable weight. Okay, before we do the experiment, we must know and measure the width, length, and the height of the apparatus. So, the width of the metacentric height is 200 millimeter, and the length of the apparatus 400 millimeter, and the height is 100 millimeter. So, before we took this metacentric height to put in the water, we must set the jockey weight into 0 and the plumb bob also into 0.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wanur Aisyah binti Wanur. My student ID is 2023 115477. So now, after we have prepared the apparatus, we need to prepare a container that filled with water. And then after everything has been centered to 0, we put the apparatus into the water and make sure that it floats. After the apparatus has been put in the water, we move the jockey weight 10 mm to the left. And we can see the differences of the angle.
My name is Ahmad Nafar Radamazi. My number is 2023 131 and 493. After 10 mm, we move the jockey weight to the left. We take the angle of inclination of the plumb bob by this measurement. So then we take the measurement of the image depth by record the current height of the pontoon, and we subtract with the initial height of pontoon, so we can get the image depth of the pontoon. Then we repeat all step for every 10 mm. We move the jockey weight to the left. That's all.
metacentric is the point of intersection of the buoyant force and the center of gravity. In order to verify the stability condition of immersed body, it is necessary to locate its metacentric point. One of those conditions is that the center of buoyancy and the center of gravity are coincident, then the body is stable. It is indicated that the stability decreases with an increase in the CG point. The lower value of metacentric height results in larger linkages of similar displacement of the treble mass. So based on the data obtained, the position of metacentric M or floating body can be identified by determining its distance from the center of gravity. Metacentric height is important to consider, especially in terms of stability. Based on the experiment, the results follow the theory as expected. The traverse mass was changed individually from 0.01 to 0.07 meter to obtain different values of angles and GM. From the result obtained, a graph metacentric height against angle of heel was drawn. It shows that the value GM increased with the increase of angle of heel. There are possible sources of errors such as human error as the parallax when taking a measurement as well as the error due to inaccurate measuring equipment. First is the water is not steady flow condition causing existence of a large wave occurs on the water while taking the reading. Second is the parallel error when taking the measurement and also error due to inaccurate measuring equipment. In order to achieve a better accuracy in measurement, a clear reference points are needed on the pantone. Furthermore, when measuring the center of gravity, must be taken to ensure the weight is completely balancing on the string and not being influenced by the other factors.
It is included that the position of the metacenter of a floating body decreases as the distance from the center of gravity increases. It also indicates that the flexibility of a floating body also decreases under this condition. The method for determining the metacentric height and its application to the stability of floating bodies has been discussed. For stable equilibrium, the metacentric height must be above the center of gravity.